Assalamu alaikum to all of you. Today I am going to discuss an important topic, that's Newton's second law of motion. Newton's second law. Newton's second law. Second law. What does this Newton's second law? First of all, you should know that अगर मैं यहाँ पे कोई भी बॉडी लूँगा ऑन द सरफेस, अगर ये बॉडी है फॉर एग्जांपल ऑन द सरफेस, दिस सरफेस, यहाँ पे कोई बॉडी है, इस बॉडी के पास एक प्रॉपर्टी होती है दैट इट डज नॉट चेंज इट स्टेट ऑफ रेस्ट, oblique motion and direction. A body cannot change itself, it is state of rest, state of motion and state of direction unless and until it is not expelled by the external balanced force, unbalanced force, external unbalanced force. Nobody can change its position of state of rest or state of motion or state of direction unless and until it is not expelled by the unbalanced external force. So we can say that एक बॉडी के पास प्रॉपर्टी होती है दैट इट डज नॉट चेंज द स्टेट ऑफ रेस्ट, स्टेट ऑफ मोशन एंड स्टेट ऑफ डायरेक्शन, एंड इस प्रॉपर्टी को हम बोलते हैं इनर्शिया ऑफ द बॉडी. इस प्रॉपर्टी को हम क्या बोलते हैं? इनर्शिया ऑफ द बॉडी. इनर्शिया ऑफ द बॉडी. Due to this inertia, a body cannot change its state of rest, state of motion and state of direction unless it is not expelled by the unbalanced external force, external agent or external cause. So we can see that greater the mass of a body, greater is the force required to change its state of rest, motion and direction. Smaller the mass of body, smaller is the force required to change its state of direction, motion and rest of the body. So we can say that as per the Newton's second law, it indicates that a rate of change of momentum divided by rate of change of time is directly related to F applied, external force applied. Momentum is a vector quantity, so it should be represented by vector. It indicates that the direction of force is same as that of the change in the direction of momentum. What does this momentum mean? Momentum is basically, if I take a body of mass m and the same body is taken to some distance from A point to B point, for example from A to B, during this then there should be the displacement of this body when the F external exerted on it, F external force. When I exert F external force on this body, it will do some displacement. So we can say that during this displacement it will take a time t interval. And we know that momentum is basically product of mass and velocity of a body. Momentum is basically product of mass and velocity of a body. So I suppose that इस बॉडी का जो इनिशियल वेलोसिटी थी वो थी u. U is the initial velocity of this body at point A, and when it reaches at point B, its velocity changes from u to v. So we can say that A point पे जो मोमेंटम है बॉडी का वो किसके बराबर है? P1 मोमेंटम ऑफ बॉडी, that should be given as m into u. What is m? M is the mass of body and u is the initial velocity of body. At point B, we can say that P2 should be given at, that's m into u v. V is the final velocity of body and mass does not change. M is constant here and m is constant here. So this should become the moment of body at point A and this should become the moment of body at point B. What does Newton's second law indicate? Newton's second law indicates that rate of change of momentum with respect to time is directly proportional to F applied, or we can say that force applied is directly proportional to the rate of change of momentum of a body. So we can say that F should be given at rate of change of momentum divided by rate of change of time. if we apply on this body, what will happen? F should be given. What is the rate of change of momentum? That should be given in this manner. Delta P should be given at P2 minus P1. This should be the rate of change of momentum of a body from point A to point B. After that, what will happen? This rate of change of momentum should be given at P2 minus P1 divided by rate of change of time t, that's t. What is the value of P2? If you look, what is the value of P2? That's m into v minus what is the value of P1? That should be given at m into u divided by t. So this equation can be further modified here. F should be given, that's m. M is constant, it should be taken out from the equation divided by t. If you look on this equation, this is initial velocity minus final velocity upon time, that is v minus u upon t is equal to a, that's acceleration. So I can replace v minus u upon t by a, so F should be given by F is equal to ma. When I replace v minus u divided by t by a. But this equation is only valid for F is equal to ma is only valid when m is constant. M, mass of body is constant. Body is constant. ये तब वैलिड है जब मास ऑफ बॉडी कांस्टेंट है. यहाँ पे मास कांस्टेंट है, आप देख सकते हो m कांस्टेंट है, यहाँ पे भी कांस्टेंट, यहाँ पे भी कांस्टेंट, यहाँ पे भी m कांस्टेंट है, यहाँ पे भी m कांस्टेंट है. So this equation is only valid, F equal to ma is only valid, or we can only use this equation when m is constant. खाली यहाँ पे इस इक्वेशन में खाली a चेंज हो रहा है, एक्सेलरेशन चेंज हो रही है. सो वी कैन से दैट ये जो इक्वेशन यहाँ पे बनी है F इक्वल टू एम ए, फोर्स इक्वल टू मास एंड एक्सेलरेशन, दैट सेकंड लॉ, ये खाली तब वैलिड है जब m कांस्टेंट है. जब m चेंज हो जाएगा तो व्हाट शुड हैपन इन दिस इक्वेशन? लुक हियर. What will happen to this equation? F equal to ma, m constant, a changes. What will happen if we take example, for example, if we take a rocket. In rocket, what will happen? The fuel of the rocket is burned and it will exhaust to the air in downward direction, and the rocket will move in upward direction because of Newton's third law of motion. So the fuel of the rocket is burned, and the mass of the rocket changes when it's moving in upward direction because burning of fuel. In that very case, this equation is invalid. You can't use this equation. You should have to use this equation, rate of change of momentum with respect to rate of change of time equal to F applied. उस वक्त ये इक्वेशन वैलिड है जब m कांस्टेंट नहीं होगा. When m is not constant, at that time this equation is not valid. उस टाइम ये इक्वेशन वैलिड है. I can differentiate this equation in this manner. Can look here that F should be given at, मैं इसको चेंज कर सकता हूँ इस इक्वेशन को. I can write it as delta P upon delta T, rate of change of momentum divided by rate of change of time. What does delta mean? Delta is a very small change in momentum and delta T is the very small change in time interval. So उसके बाद मैं क्या करूँगा, ये जो F applied है इसको मैं ऐसे भी लिख सकता हूँ, F equal to rate of change of momentum D. P किसके बराबर है? P is the momentum, P equal to mass into velocity. So I can write it as P equal to m into v divided by delta T. This should be also the Newton's second law of motion. It is the differential law. So first of all, I will come out m from the equation. F should be given at m को बाहर करो equation से, it should be given as delta V upon delta T. So this equation is also Newton's second law. How? F equal to ma. This is rate of change of velocity. Rate of change of velocity divided by rate of change of time. This is acceleration. So I can write this equation further. F equal to ma. F equal to ma. In second case, I can also out V. So I can write this equation in this manner also. F equal to m. m को मैंने बाहर किया इस इक्वेशन में. अब मैं यहाँ पे v को बाहर करूँगा. v equal to dm upon dt. What does this mean? This is also Newton's second law. This is rate of change of mass with respect to time. If it is 0, then the force applied on the body is 0. So we can say that Newton's second law is perfect. This is perfect in Newton's second law, this equation. Why? Because we cannot use this equation when the mass is changing. When mass is changing, at that time we use this equation. So we will start to apply this Newton's second law. What it basically is, you can look here that. What is Newton's second law? Look here. If this is a body, for example, if this is a body, it is on the surface. If m is the mass of body and I apply a force F on it, I have to calculate the acceleration of the body. If you look on this body in this manner, the weight of the body should be downwards. That should be given at mg, and the surface will exert the normal force on the body in upward direction in this manner, and acceleration of the body is in this direction because the applied force is in this direction. I have to calculate the A, mg and n should be equal to how? Because if you look, if you make a structure of this is A, this is applied force F, this is normal reaction, and this is mg. Because the body is moving in this direction, in forward direction, so body is not moving in downward or upward direction. The acceleration of the body is in this direction, so mg should be equal to n. Mg equal to n. Then the acceleration of the body should be given as F equal to ma. That should be given as A should be given as F equal to m. This should be the acceleration of this body. This was first example. Second, if you look here that if I take a same body, if this is the same body of mass m and it is placed on the surface, if I apply force F2 here and F1 here, if I apply two forces on this same body, what will happen? I suppose that F2 is greater than F1. Then what should happen? The acceleration of body should be in this direction because F2 is greater than F1. If F2 is 15 Newton, F1 is 10 Newton. So 10 minus 15 is 5. Net acceleration of the body should be in this direction. So we can say that if we make a graph of this mass, for example, weight of the body should be in downward direction given as mg, acceleration of the body in this direction, and normal force is in upward direction. So we can say that the total force on this body should be given as, because the acceleration of the body is in this direction, so F2 should be taken as positive. So net force should be F2 minus F1 equal to mg. Because we should have to take the positive that very term in which the acceleration of the body is going. So we can say that यहाँ पे मुझे अगर mg and यहाँ पे जो acceleration है, it is due to motion, so I can replace it by a. That should be equal to F equal to ma. That should be given as, if I have to calculate the value of a, it should be given as F2 minus F1 divided by m. This should be the acceleration of the body when the two different forces are applied in opposite directions. If you take another example, for example, if you take a body on the surface of same body of mass m, if here is the force applied on this body, F is applied here, I have to calculate the acceleration of this body. How I can calculate? If you look, this is the force. I resolve this force. This should be F cos of theta, and this should be F sine of theta. F sine of theta. After the resolution of this force, what will happen, this force should not be, इसको हम फिर neglect कर सकते हैं because of the resolution. So we can make this in this way. What should be the acceleration of this body? If you look, mg is downwards, normal reaction in this direction, f sine theta in this direction, sorry, f sine theta is in upward direction, f sine theta is in upward direction, f sine theta is in upward direction, and f cos theta is in, f cos theta should be in this direction, f cos theta. So the total force, if you look on this measurement in this manner, this is normal reaction, this is f cos of theta, this is mg, and this is f sine of theta, f sine of theta. It indicates that n plus f sine of theta, if you look, is equal to mg. If you look, normal reaction is in upward direction, n is in upward direction, and f sine theta is also in upward direction. So f plus n should be given as mg. They should be equal to each other and cancel out each other. So what should be the net force on this object? This should be f cos of theta equal to ma. So if you have to calculate the a, you can calculate a equal to f cos of theta divided by m. This should be the acceleration of this body, because f sine theta is in upward direction, normal is in upward direction, and mg is in downward direction. So f sine theta plus n should be equal to mg. If you take another example of the second law, here, look here, if I have two bodies, for example, this is m1 body and this is m2 body. If they are placed on the same surface, look here, they are placed on the same surface, if they are placed in the same surface, if I apply F force here on a body of mass m1, I have to calculate the acceleration of, what is the acceleration of whole system. Look here, when I apply this force on m1, then there should be the acceleration of mass m1. m1 will accelerate in this direction and m2 will also accelerate in this direction. First of all, I will look on this m1 mass. If this is m1 mass, then there should be, weight should be in downward direction and normal reaction should be in upward direction, and this should be the applied force and this should be the acceleration. mg in downward direction, n in upward direction, acceleration in direction, and force in also in this direction, F. What should be the net force on this object? It should be given as, if you look, acceleration is in direction, so I can write F minus, यहाँ पे जो फोर्स लग रहा है पहली बॉडी को वो इस डायरेक्शन में लग रहा है, तो F should be given at F इस डायरेक्शन में लग रहा है, तो वहाँ पे क्या हो रहा है, ये जो ये बॉडी है ये नॉर्मल रिएक्शन इस डायरेक्शन में इसको अपोज कर रहा है, तो इट शुड बी गिवन एज F into n इक्वल टू ma. हाउ? लुक हियर दैट, अगर ये यहाँ पे एक बॉडी है, ये है दूसरी बॉडी, इन दिस मैनर, हाउ इट कैन बी सॉल्व्ड? ईजी है, यहाँ पे m1 मास है तो यहाँ पे m2 मास है. जब मैंने इसको फोर्स अप्लाई किया तो ये जो यहाँ पे इनके बीच जो वाल है, m1 ने नॉर्मल रिएक्शन n डैश रिएक्शन m2 पे लगाया और m2 ने n2 पे, n2 नॉर्मल रिएक्शन m1 पे लगाया, यानी m2 ने इस डायरेक्शन में नॉर्मल रिएक्शन लगाया, m1 ने इस डायरेक्शन में नॉर्मल रिएक्शन लगाया, तो नेट एक्सेलरेशन तो इसी डायरेक्शन में है क्योंकि अप्लाइड फोर्स इस डायरेक्शन में है, तो यहाँ पे जो नेट फोर्स होगा इस बॉडी में m1 में, वो क्या होगा, F टोटल फोर्स कितना लगा माइनस n। ये n कौन है, ये n है m2 का नॉर्मल रिएक्शन ऑन m1, नॉर्मल रिएक्शन ऑफ n2 ऑन n1, यानी इस मॉस m2 ने नॉर्मल रिएक्शन डाली m1 पे, वही है यहाँ पे ये n। ठीक है, तो ये किसके बराबर है, मास इनटू एक्सेलरेशन। यहाँ पे मैं लिख सकता हूँ m1 बिकॉज ये मास फर्स्ट है। तो अगर हम सेकंड बॉडी की तरफ देखेंगे, अगर यही आप लोगे, यहाँ पे है फर्स्ट बॉडी और ये है सेकंड बॉडी। लुक हियर, ये है m2 मास, तो m1 ने m2 पे नॉर्मल रिएक्शन डाला एज n डैश, और n2 नॉर्मल रिएक्शन ऑफ m2 ऑन m1। सो जो टोटल फोर्स होगा इस पे, इस बॉडी पे, इसको नीचे की तरफ होगा mg, ऊपर की तरफ होगी नॉर्मल रिएक्शन। तो जो नेट फोर्स होगा ऑन m2 वो किसके बराबर होगा, वो होगा n2, यानी नॉर्मल रिएक्शन शुड बी गिवन एज mg। तो इफ वी ऐड दिस इक्वेशंस, व्हाट विल हैपन, वी विल ऐड हियर n2 इक्वल टू m2a। we can replace g by a because it is an acceleration due to motion, it is not due to gravity, because we are applying force here. So this is basically ma here, this should be given as ma. So I can write this equation in this manner. You can look here, if we add to these equations, what will happen, n and n2 should be cancelled. How? Because जितना m2 नॉर्मल रिएक्शन डाल रहा है m1 पे, उतना m1 m2 पे डाल रहा है। जितना नॉर्मल रिएक्शन m1 मास डाल रहा है m2 पे, उतना m2 मास डाल रहा है n1 पे। They should be equal but in opposite, so these can be cancelled out each other. What will happen, F should be given at m1a plus m2a. So this can be given at, F should be given at, F a should be given at F divided by m1 plus m2. This should be the acceleration of the whole system. We can directly write it as a should be given at F divided by m1 plus m2. How? Because जो फोर्स है हमारे पास वो है mass into acceleration. Acceleration should be given at force divided by mass. So there are two masses, m1 and m2. You can directly substitute the value m1 and m2. Thank you. If you understand, thank you.